How do you deploy a fine-tuned LLM model to production? Deploying a fine-tuned LLM into production is like turning a prototype into a real product people depend on. You begin by choosing a cloud environment with GPUs, which is what most companies use because it handles heavy workloads without stalling. Then you containerize the model so it behaves consistently everywhere, just like sealing a recipe inside a lunchbox so the taste never changes. After that, you expose it through an API so real apps can call it. For example, a customer support bot can send a message and get a response in milliseconds. The final stage is monitoring, where you watch latency, errors, and cost, and scale up when traffic spikes. If asked about optimization, you can mention caching or using a smaller, quantized version for faster responses. This simple four-step story, platform, container, API, monitoring, is exactly what interviewers look for because it mirrors how real teams ship models today. Understanding the deployment pipeline. A good way to understand the deployment pipeline is to picture a carefully organized assembly line. It starts with the model registry, which acts like a library, where every trained version is stored, along with notes on how it was built. This is crucial in real teams because it lets engineers trace issues back to the exact training run. Then comes containerization, where you bundle the model and its environment so it behaves consistently across machines. After that, you push it to the cloud, often onto Kubernetes or SageMaker, which companies choose because these platforms restart services automatically if they fail. Finally, you monitor and refine the system, watching user patterns and rolling out improvements gradually. A concrete example is updating a model weekly and using the registry to track which version improved accuracy. Interviewers love when you highlight that these steps reduce surprises and make the system reliable as it grows. Key technical components. Running an LLM in production feels like managing a busy kitchen, where every second counts. Serving tools like TorchServe or TensorFlow Serving act as disciplined chefs who know the exact cooking steps. Performance tools like ONNX, Runtime, and Triton act like specialized appliances that make the work faster and more efficient. Quantisation is a great example of this speed-up. Imagine shrinking a 6 GB model down to 2 GB so it loads faster and answers more quickly without losing much quality. On top of that sits the API layer, where fast API handles requests smoothly. NGINX spreads traffic across servers, and authentication ensures only approved apps can call the model. If an interviewer asks what breaks under load, you can say that without load balancing or quantization, even simple tasks slow down like a kitchen stuck during a dinner rush. This slide shows you understand both speed and safety in real systems. Critical follow-up questions you'll face. Interviewers love to explore what you do when things get messy in the real world. For versioning, imagine keeping multiple drafts of an app and promoting only the stable one. Tools like MLflow make this easy. For latency optimization, you might shrink the model or pre-compute common answers. Drift is another key example, and it's simpler than it sounds. If you deploy a model in January, and by June users start using new slang or new product names, the model slowly drifts away from reality. Rollbacks save you here. If a new V2 update starts giving inaccurate results, you instantly switch back to V1 while investigating the issue. Scaling is just adding capacity when demand jumps, like opening more checkout counters in a store. Showing calm, practical understanding reassures interviewers that you can keep a live system stable even when behavior changes. Production deployment best practices. Keeping a production model healthy is like caring for a living ecosystem, where every part needs attention. You start with thorough testing, so hidden issues don't surprise users later. Then you log every request, because logs become your map during outages. For example, if latency spikes at 2 p.m. every day, logs tell you exactly why. Alerts act like early warning sensors, letting you catch problems before users complain. Documentation helps teams fix issues quickly, especially when engineers rotate on-call duties. And planning updates carefully prevents outages. Real companies often release updates gradually, so if a bug appears, only a small percentage of users see it before rollback. Interviewers appreciate when you emphasize that the real goal isn't just launching a model, but keeping it reliable, month after month. A steady system earns user trust, and that's the heart of good production engineering. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.